Assalamualaikum and welcome back to our chapter 5 fatty ester. So we will continue on the process of the process of to obtain our fatty ester. So as you can remember, we have two. First is from the trans esterifications of oil and fats. Another method is through the esterifications of the fatty acids. Okay, so we proceed with our second method, which is the esterification. Okay, esterification is actually the process of to obtain your ester through the dehydration process by react of your carboxylic acids and alcohol to produce your ester and water. So the process is called as the dehydration since it is removing the water here. Okay, so the esterification is a chemical reaction used for making an ester. So the reaction in which a carboxylic acids combine with an alcohol and with the help of the catalyst such as concentrated sulfuric acids will form an ester and is called the esterification reaction. So it is a reversible reaction. That means by the reactions of the ester and water you can get the fatty acids. So example here is the acetic acid esterification in excess ethanol in the presence of the catalyst H2SO4 will result the products of acetic acetates and the water molecule. Okay, so another name for your esterification is the dehydration reactions. So the chemical compositions of the acids, alcohol and catalyst use also affect the rates of the reaction. So the choice of the strong acid will make the rates of formations of your acids is much more faster. Okay, this is the chemical equation to produce your fatty ester. So fatty acid, your carboxylic acid, and your alcohol, your carboxylic acid react with your alcohol, and then this portion is the water where we are going to dehydrate our water. So the process requires heat, and here the H plus is your catalyst H2SO4. So the water being removed here, so we have the remaining RC double bond O and OR from your alcohol fragment. C double bond OR is the acid fragment from the carboxylic acid. OR is the alcohol fragment. So the other component will be H from the alcohol and OH from the carboxylic acid will produce water. Okay, this is the process flow diagram to produce your fatty ester. So your methanol will fed to your reactor from the bottom and the fatty acid come from the top together with your catalyst. So the reaction occur here and the products of the fatty ester will be removed at the bottoms and your remaining alcohol will be recycled back to your alcohol tank. So the products of the fatty ester will go to the flash and then to the distillation column to separate and your methyl ester and the remaining the residue or your water. Water, if we introduce vacuum, it may be removed from the top. Okay, so at the tops of the column, fatty acid is introduced. Okay, as you can, as I explained earlier, the fatty acid will come at the top, and your excess methanol will come from the bottom. Okay, the process occur here until you get your methyl ester. Okay, the process is countercurrent. That means it has different direction feed for your methanol and your fatty acids. Okay, what are the difference between your fatty methyl ethyl ester and fatty acids, or we call it as the fatty acid methyl ester as the FAME and fatty acids. So fatty acid is more corrosive, while your fatty ester is not non-corrosive. Second, the process to obtain the fatty FAME is from the directs of your fats or triglyceride. We call it as the transesterification. On the other hand, for your fatty acid, the process to produce is a fat splitting process. For FAME, it is required low boiling point and it is easy to be distilled. As compared to your fatty acid, it is very high boiling point condition to operate. And the fatty acid methyl ester, the heat required is more stable. As compared to your fatty acid, it is less stable. So we need to control the heat. Any slight change in the heat will affect the products. So that's why it is less heat stable for your fatty acids. Okay. Okay. Now you need to answer all these questions and submit by today. Thank you.